This is the ending question from the previous video. For the part B, when x equal 1, this is x equal 1, the point is right here. So we draw the horizontal line to hit the y-axis. The y is -2. Okay. Not the -1 because for each unit is a 2. Okay, sorry. For each unit is 4. So this will be the -4. My bad. So when x equal 1, y is equal -4. So now we are going to continue the part 4, determine the domain and the range of the function from the graph. Both the domain and the range of the function can be identified by viewing the graph of the function. So finding the domain, we just simply to look at the horizontal axis, which is look at your x-axis. That will determine the interval of your domain. Finding the y, this is domain. Finding the range, we look at the lowest point on the y up to the highest point on the y. So this will be the range. So we look at the example. Use the graph of each function to determine the domain and the range. So this one, the domain of this function, as here you can see, it will go to negative forever and you will go to the positive forever. There is no gap. There's no cut in the between. So the domain will just negative infinity, comma, positive infinity. For the range, we look at the lowest point on the y-axis up to the highest point on the y-axis. So here you can see there's a down arrow. So that means it will continue going down forever. So the range, the lowest point on the y-axis would be negative infinity. The highest point on the y-axis is here. So this will be the highest point. 1, 2, 3, 4, 5. So you're 5 and put a bracket because this is endpoint. Look at the part B, the domain. Same way, it will continue go to forever on the negative infinity. It will continue go to forever to the positive infinity. So the domain will be negative infinity to the positive infinity. Range. The lowest point on the y-axis is here. So this is the lowest point, 1, 2, 3. So we put a bracket, -3, comma. It will continue go forever going up. So it's a past infinity on the range. And we put a parenthesis here because this is infinity. Nobody knows where is the endpoint. Now we look at the C. C here. On the left, most of the left hand side, it has an arrow. So you tell us it will continue go to negative infinity forever on the horizontal line, on the horizontal axis. So we write down the domain, start from negative infinity, comma. The most right hand side, it comes with the arrow as well. So we know it will continue go to positive infinity forever. However, here there's a gap. But this one comes with a circle. This point comes with a closed dot. That means when the function comes to the x equal 2, this closed dot will replace this open circle. So in fact, it replaces it. So the function is continuous. There's no gap, no longer, because the closed dot replaced this open circle. If the case is both of the endpoint here is open circle, then this will be a gap. But this is not a case because this closed dot replaced the open circle. So the domain of this graph will be negative infinity, comma, positive infinity. The range, the lowest point on the y-axis is here, which is 2. So we put a bracket 2, comma. The highest point on the y is here. It will continue to go through forever. And there is no gap because this y interval here, this graph has been covered. So there is no gap. So the highest point on the y would be infinity. Look at the d. The d function here is the rational. So you have negative infinity go to the right hand side forever. And there is a gap here. We call asymptote. So the way you represent the domain would be negative infinity, comma, 1. Because when it comes to the 1, it's shut down. Open parenthesis, because this is asymptote. It's not the endpoint. Union, open parenthesis, start from 1, comma, go to infinity. The range, the lowest point on the y is negative infinity, comma. When they come to the 0, when the graph comes to the y equals 0, it has a gap, tiny gap here. So put a 0, union from 0 to the infinity. Alright, so recognize the graph of common function. So these 6 common functions that occur frequently in algebra, these graphs are sometimes referred to the basic function or parent function and can be sketched by plotting points or generated using a graph calculator. These common functions are the building block for graphing more complicated functions in algebra. So this function, I highly recommend you memorize it or sketch the graph, practice them very, very often, then you'll remember. So the first type of the function is a segment, right? It's a straight line. It toward to the positive forever and the negative forever. So we call this as a linear function. Linear function. So you have the domain is negative infinity to the positive infinity. And the range has negative infinity go to positive infinity as well. So the first one is a linear. The second graph is a parabola. So the basic function of the parabola is f of x equal x squared. So we call the squaring function, but most of the time we call it the quadratic function. Quadratic function. So the curve itself is passing through 0, 0, and it has a symmetric half and half. They're symmetric to each other. This function we call the cubic function. Cubing function. So you have f of x equal x power 3. It's a kind of river. Start from quadrant 1 and you passing through 0, 0, and continue drop down on quadrant 3. So the domain and the range of this function is negative infinity to the positive infinity. So the domain, when we represent the domain, let me put down here, we from left to the right. From left to the right. When we represent the range, we go with the lowest to the highest. That's the way we represent. That's a pattern. We represent the domain and the range. Absolute value function is a V shape. The parent function of the absolute value function, it will pass into 0, 0. So the domain will be negative infinity to the positive infinity. And the range, the lowest point on the parent function of absolute value function is 0. So the range is 0 bracket to infinity. Square root function, the domain is from the starting point at 0, so put a bracket 0 to the forever, to the infinity, and the range, the y value is 0 as well, so put a bracket 0 to the infinity on the y-axis. Cube root function. So the cube root function is the a cubist root. You have the index number 3 on the outside of the root sign, so we call cube root. So the cubic root, the domain of the cubic root function is negative infinity to the positive infinity. The range is negative infinity. It will keep going down to the positive infinity on the y-axis. This is question from your assignment. So you need to find the y value equal, when y equals -4, what would be the x value? So just go to label the y equal -4. -4 is down here. 1, 2, 3, 4. So determine the y value -4. Now you go find the point that represent the y equal -4, and then look at your x-axis. So when y equal -4, your x equal 5. Finding the x equal 3. When x equal 3, what is the y value? So x equal 3 is here. So when x equal 3, the only point on the graph will be this point. So when x equal 3, the y is -25. So this is section 3.1. You can move on to work on web design.